This problem, we've mixed 20 grams of phosphorus, 15 grams of water, and 30 grams of oxygen, and we form 50.3 grams of H3PO4. So what we want to solve for is the percent yield, and the percent yield is equal to the actual yield over the theoretical yield times 100. And the actual yield is the 50.3 grams. So we need to know what is the limiting reagent and what is the maximum amount of phosphoric acid we can produce. Now I'm going to do this the quick way. And the first thing we do is I write down underneath each thing what its mass is. So I have 20 grams of this. So I'm going to put slashes through my zeros because this is an O, and that way we can distinguish zeros from O's. And I know that this number has 3 sig figs, 3 sig figs, 3 sig figs, but I'm going to leave it shorter as I'm working it out in order to have more room on the chalkboard. So I have 30 grams of oxygen, and I have 15 grams of water. Okay? And this is for the water. And I'm just going to erase this for now. The next thing I need to know is to calculate the limiting reagent. I need to know the formula weight of each of these things. So this has a formula weight of 30.98 grams per mole. Now I could over here say mass is equal, formula weight equals. Oxygen has a formula weight of 32.0 grams per mole, and water has a formula weight of 18 grams per mole. Now I don't want to spend all day solving this, so I need to identify the limiting reagent. So I know if I take the mass of this, divide by its formula weight, and divide by the coefficient, I get a 0.161. I take the mass of this, divide by the formula weight, divide by the coefficient, I get a 0.188. I take the weight of this, the mass of this, divide by the formula weight, divide by the coefficient, and I get a 0.139. Now whichever of these is smallest, I multiply by the coefficient of this, and then I multiply by the mass of this in order to come up with the formula on the theoretical yield. So this is the smallest, this is the limiting reagent, these will have excess. So I take the 0.13, I multiply by 4 moles of H3PO4, and then I multiply by the formula weight of H3PO4, which is 97.995 grams of H3PO4 per mole. Okay? And now I get out my calculator, and this would be equal to 54.5 grams. And this is the theoretical yield. So the percent yield is equal to the mass I actually have, 50.3 grams, divided by the theoretical yield, which is based on the complete consumption of the limiting reagent, at times 100, and this is equal to 92.3%. Now this is the fast way to solve this, okay? And if you get confused at this point, you can start from the beginning. You could say 15 grams of water. I'll write it here in red. I have my 15 grams of water, and I divided by its molar mass, 18 grams per mole of H2O. And then what you did is you divided by its coefficient, 6 moles of H2O. And that number was this number. Then you multiplied by the coefficient of the thing you wanted, 4 moles of H3PO4. And you multiplied by 97.99 grams per mole. Okay? So you didn't have to repeat this. If you take the mass of this, divide by the formula weight, that tells you the moles. Divide by the coefficient, and do that for each species. Then when you have the smallest number, multiply by the coefficient of the thing you want. And if you ask for mass, multiply by the formula weight of the thing you want. And then you can solve this problem.